That's all I was doing. Okay, ready. Yes, what am I doing?
Well, the question is, I didn't see the answer.
Tangent 39 degrees is the opposite leg over the adjacent leg. So tangent 39 equals x1 over 325. When we cross multiply, x1 is 325 times tangent.
Okay.
And in the same way, we get x2. And then we plug them in. This time, we are looking for x, which is x1 plus x2. In this problem, we were looking for x2 minus x1, a relationship that will eventually, we were hoping that it only has x age in it. Is this better?
Yeah, I think what threw me off was that I was doing the sine up the side of that.
No, so when you're not given the hypotenuse, you can never think in terms of sine and cosine. And the hypotenuse is not given here. Very good. Anything else before we continue with 6.3? There are different problems in 6.3 that I would like to look at. I think we're okay with the reference angle, right? We don't have difficulties in finding the reference angle unless you say, show me another example. Reference angle. Are we okay with the reference angle? Yes? Okay. Find the exact value of the trig function. Here I would like you to choose anything you want, 11 through 44. Find the exact value of the trig function. We're going to do that for all trig functions, for any angle. So please choose 11 through 34 on page 559. (459), 11 through 34.
Four.
Which one?
But you said 559 first.
Oh, I'm sorry. So you can now consider all these after we finish 6.3. We did not finish 6.3. But then when we are done, you can consider all these done.
Okay.
So now, because Paul asked me, okay, what happens next? Well, these are the trig. I don't like the sequence. I can't do this. I have to show you 5, 3, 5, 4, 5, 5, and then come back to 6, 4, 6, 5, 6, 6, only because, for example, 6, 4 deals with inverse trig functions. I have to explain what inverse trig functions are and how we get them. So I can't continue with 6.4 without showing you these 3 sections. So once we are done with 6.3, we're going to jump to 5 and then come back to the other 3. Okay, so 11 through 34, forgive me, on page 459. This is in section 6.3.
So, what's the question? Are we just using the calculator? Or?
No.
Oh, okay.
Find the exact value.
Yeah.
Yes. Find the exact value.
The ratios.
Right. And then here I would like to show you, after we look at more problems, I only need to show you another way of finding the area of a triangle. I'm ready. Did you pick anyone? This is a very good exercise. Which problem? 29? Yes?
Yeah.
Okay.
17 pi over 3.
Secant 17 pi over 3. And this is 29 on 459. Very good. Number 1. This is secant. I refuse to think in terms of secant. I'm going to calculate 1 over cosine 17 pi over 3. No one can force me to think in terms of secant, and I will not. I will always go back to the basics. Always go back to sine and cosine. What do I care about secant? It's going to give me the same number anyway. Very good. So thinking in terms of cosine, I have to go around the unit circle. Why? Because I don't know where the terminal side is. I don't know whether this number is going to be positive or negative.
Right.
If it lands on the right-hand side, of the y-axis, the number will be positive. If it lands on the left-hand side of the y-axis, then the number will be negative because cosine is measured on the x-axis. Okay, so now I do know what this means, because if you tell me 17 pi over 3, I'll say, what? But once you say 17 pi over 3, and I know that this is 60 degrees, I will know exactly what it means. So 17 times 60, 2 and 4, 10. And then I will divide it by 360 to find out how many complete rotations are in this. You can also divide by 2 pi if that's easier for you, right? If you divide 17 pi over 3 by 2 pi, you will know the same thing because 2 pi is complete rotation, 360 is a complete rotation, right? So 1020 divided by 360 is 2.83. So 360, if you want multiplied by 2, is 720. So it's 2, so this is twice 360 and plus 300. Two times 360 is 720. 720 plus 300 is 1020. Agreed? Is this okay?
Yeah.
Nico, are you okay?
Yeah, what, you have it written like 1760?
Yes. You remember pi over 3?
Yeah.
Pi over 3 is 60. And then I multiplied 17 by 60 and I got 1020 degrees.
Okay.
And then I said, okay, how many complete rotations are in here? Well, there are 2 complete rotations. That's 720. Plus 300 is 1020. Correct?
Mhm.
So,
How would I do it?
I'm sorry?
Okay, so if I did it from using 2 pi, it would just be
You have to take the integers out. So if you want 17 pi over 3, you will write 5, right? So 5 plus 2 pi over 3.
okay.
5 times 3 is 15. 15 plus 2 is 17. Of course, 5 pi, of course. So 15 pi plus 2 pi, 17 pi. But so you're going around the circle. It's slightly more difficult because you're going around the circle 2 pi, and the pi, and now you have to add 120 to it. It's 2 times 60. So it's up to you, whatever you want. But we have to establish which quadrant. And now I know that this don't count because I go around the unit circle twice. It doesn't matter. And then 300 degrees, this is 270, right? And I have to go 30 more. So this is 1, 2, and I stop where? Shy of 360 by how much? Yes.
Do we have to do that on your questions? Do we have to like show the little spiral?
So the only thing that I need you to say is the reference angle is, and remember the reference angle is always a positive angle. How much is the reference angle?
60.
Right, or pi over 3. Very good. We are talking about cosine. Since the terminal side ended on the right-hand side of the y-axis, what type of number will be cosine? Positive. So then I know that cosine 17 pi over 3 will definitely equal what? It has to be cosine, yes. Yes, if you want to emphasize that, that's fine. It must be cosine of the reference angle. So it's either positive cosine of the reference angle or negative cosine of the reference angle, right? Because the reference angle is an angle that shares the initial side and the terminal side with angle 17 pi over 3. In other words, look here for a second. This height is sine, I don't need it, this height is sine of 17 pi over 3, and this piece is
Cosine.
right. It will definitely be the same piece with cosine pi over 3. It will be negative sine pi over 3, however. And now since I know what cosine pi over 3 is, remember, pi over 6, pi over 3. 1/2, 1/2. The square root of 3 over 2, the square root of 3 over 2. So what does cosine pi over 3 equal to? Okay, so let's do this again. So we have sine, we have cosine. We have to write it a few times before we are very comfortable with this.
Yeah, that's
Pi over 6, pi over 4, pi over 3. Here's how I do it. So how much is cosine pi over 3?
okay.
That's it. However, this is not what I'm asked. I was asked to find secant 17 pi over 3, not cosine. I want to go to basics. I don't care about cosine. Once I have cosine, well, I don't care about secant. Once I have cosine, I have the answer. So what is the answer then? That's all I'm asking you to remember. And of course, in addition to that, I'm asking you to remember these points. And cosine is the x-coordinate, and y is sine. That's all I'm asking you to remember. So here I have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. The first coordinate is always cosine, because cosine is measured on the x-axis. The second coordinate is always sine, because sine is measured on the y-axis. Okay, would you like to choose another, or we move on? We're going to have plenty of examples like this. Do we need another right now, or we move on to other types? Another one? Okay, so let's choose another. Please choose. 11 through 34. Yes?
You do 100 degrees there, right?
I'm sorry?
19.
You said 19? Okay, very good. So cosine 570 degrees. Very good. This is nice. It's one of the basic ones, sine and cosine. I don't have to worry about converting it from the slightly more sophisticated one to the basic one, sine and cosine. It's cosine. Very good. So I subtract from 570 degrees, I subtract 360, which is a complete rotation, and I get 210. That's all I need. So on the unit circle, I know I go around one complete rotation, and then 210. This is 180. So I go 210, how much more? Right, so I divide this in 3 equal parts. So this is my angle. I need to identify the reference angle. What is the reference angle?
30 degrees.
Very good. So now you will say cosine 570 degrees is definitely the same with?
Negative
Awesome.
cosine.
That's it. And how much is cosine 30? Not 1/2.
Yeah.
I didn't say you said that. I just wanted to emphasize. It's not 1/2. So the answer is?
Square root of 3 over 2.
Yes, with minus.
Negative square root of 3 over 2.
That's it. This is how we determine the trig functions of any angle on the unit circle. Now, what if I'm asked to determine cosine of 100 and 67 degrees. Exactly. I can't do it. I can only do it if it's one of the endpoints, or if it's 30, 60, 90. 30, 45, 60. For the rest, my hands are tied. So cosine 167, but you will learn in the next class how to do it without a calculator. You will be able to approximate, not have an exact 100%, but you'll be able to get 4 or 5 decimal digits accuracy. The next class will be very powerful. So it's negative 0.9743. Okay? Very good. So approximately negative 0.9743. Perfect. Okay, let's move on to the next set. Find the quadrant in which theta lies from the information. Yes, I need that. Please choose. We're given information, whatever, 2 pieces of information. We're asked to find the quadrant in which theta lies from the information given. Which one? Okay, 36. Tangent theta is less than 0. Sine theta is less than 0. When you identify the quadrant, you have 2 ways of identifying it in the quadrant. You can write it as theta between this and this, or you can write it as theta belongs to quadrant. I will write both for you. So, I look at sine.
Yes.
Where is sine negative? Say it again. That's cosine. It's below the x-axis. Sine is measured on the y-axis. Where is sine negative? Below. Very good. Awesome. This is done. Tangent. Where is tangent negative? Tangent is negative when sine and cosine have opposite signs.
Right. So
Opposite signs.
2 and 4.
Yes. So this is for tangent, and this is for tangent. There is only one quadrant that fulfills both conditions at the same time.
Right.
Which quadrant is that?
4.
4. So you either write theta in 4, that's one way of writing it, or you write theta between 3 pi over 2 without the equal symbol and 2 pi, or 270 degrees theta 360 degrees. But you cannot keep the equal symbol. So you can write it one of these 3 ways. Theta in 4, or theta between 3 pi over 2 and 2 pi, or 270 and 360. Okay, next problem. Write the first trigonometric function in terms of the second for theta in the given quadrant. Any questions on this? Is this okay? Okay, next one. Write the first trig function in terms of the second one for theta in the given quadrant. So please choose here. 39 through 44. I'll explain what it, yes, it's a little bit confusing. 42. So we want secant theta, sine theta, let's write it like that, and theta in 1. So they want us, again, you picked 42 on page 460, and this is secant theta in terms of sine theta for theta in, is that what you picked?
Yeah.
For theta in 1. Okay, very good. One more time. Find the value, I'm sorry. Write the first, I read from something else. Write the first trig function in terms of the second one. Right? Write the first trig function in terms of the second one. So,
Right, secant in terms of
exactly. I don't even care what I'm asked to do. The only thing that I can think of at this point in time for secant, there are 2 things that I could do. But secant theta equals, excellent. And at the beginning of the class today, we solved the basic trig function for cosine or for sine. So I want to go back to that and replace cosine by what it equals in terms of sine. What was it? Remember, we moved sine and we took the square root. Right. Square root of,
1 minus sine, square root theta.
very good. But now I'm asking you this. Theta is in the first quadrant.
Right.
What sign, not signs, right? What sign can cosine have for sure?
Positive.
So there is no point in writing plus or minus. I'm going to erase it. So we wrote secant in terms of sine for an angle in the first quadrant. What if the angle were in the third quadrant? What would the answer have been? Secant theta would have equaled -1 over the square of 1 minus sine squared. Is that okay? Very good. Next set, 45 through 52. Find the values of the trig functions of theta from the information given. Okay. 45 through 52.
Of all of them?
Which one?
One saying is asking to find the values of all the trig functions.
Yes, find the values of the trig functions of theta. Yes. We are given one, we have to find the other 5 from the information given. Yes. So 45 through 52.
About 52.
52. Very good pick. So tangent theta equals -4. We'll allow you to pick some other time too. Just kidding. No matter what, you're allowed to. Okay, ready? So what is this question requiring us to do? Is it asking us to do? We're given tangent. We're also told that sine is a positive number. And we're asked actually to find sine, cosine, cotangent, secant, cosecant. We're given tangent. So sine, cosine, cotangent, secant, and cosecant. Very good. My first thought is, yes, you're right. I could determine cotangent in a blink. Cotangent theta equals. Very good. So that's done. I agree. However, my first thought is, wait a minute. I have to establish the quadrant where theta is, because otherwise I will have difficulties with that plus or minus. If I determine sine, it's going to be plus or minus. It's going to determine cosine, it's going to be plus or minus. I don't want to deal with that. So I'm going to go to the circle, the unit circle if you want. I'm going to say tangent is negative where?
2.
Very good. And I'm going to say sine is positive where?
1 and 2.
So therefore, I know exactly where the quadrant is, or where the terminal side of angle theta, where theta lies, is. Which quadrant?
2.
In 2. If theta is in 2, then I know for sure sine, when I get to it, sine theta will be, cosine theta will be, I have tangent and cotangent, secant theta will be, very good, and cosecant theta will be positive. They have to wait. I'm not there yet. But I already established a sign based on establishing the quadrant. Yes, Paul?
Yes, we already knew that sine was positive.
But we didn't know whether,
The other ones.
because, no,
Well, I mean,
you
I'm
don't.
thinking if we knew sine is positive and the tangent was negative, would it have to be in that quadrant?
Well, so tangent and cotangent are both negative, but it could only be if you look at this, right? If you say tangent and cotangent are negative, so it could be this or this.
Yes, but sine is not positive in that.
Because sine is positive. Yes, it must be the second quadrant.
Instead of having to do the circle, I mean, I like the circle.
That's fine.
The circle's bad, but I'm just saying that.
That's good
because they
enough.
told us where sine was,
I agree.
The only place it could be is that one.
I
Because
agree.
That's the only time sine's positive.
I
and
agree.
That's positive. And that's when we're cosine's negative. Because they gave us.
I agree. Completely agree. Very good. So now I have to come back. And I have to look at tangent. That's what I'm given. I'm given tangent. I don't have sine and cosine. This is basically one of the most difficult situations in which I don't have sine and cosine. Or one of them.
Right.
If I had sine, I would have been
Good to go.
good to go. But I have tangent. However, I have the most important identity that we talked about. Can anyone give it to us quickly? Sine squared
Minus cosine squared
plus,
plus cosine.
right? Because it's the triangle in the unit circle.
Right.
So sine squared plus cosine squared is. But from there we can determine two more identities, and one of them has tangent in it. Which one? Remember, they are paired. I would like you to start remembering them in pairs. Sine with cosine, and tangent with secant, and cotangent with, that's it. So can anyone give us the relationship that we have now and has tangent in it?
Oh, it's about tangent squared out theta plus 1
Exactly.
equals secant.
That's what I want. Good.
I'm trying to do this right.
So I have tangent, right?
Yeah.
So I'll plug it in. 1 plus
-4. Oh, 4. 16.
secant squared. So then I know that secant squared equals 17. Secant will be, how do I determine secant from here? Good, but I will not put plus or minus because I already established a sign. So then secant theta equals negative square root of 17. If I have secant, which other trig function I have right away? Exactly. How much is cosine? And I have to rationalize this. So this would be negative the square root of 17 over 17. Now I have two ways. I go back to the third identity so I can practice that. Or, which is uglier, I have cosine. And I have a relationship between cosine and sine, and I can determine sine. It's up to you. So we can determine sine using cosine, or we can determine sine from the third trig identity that we looked at. It's up to you. If you want to practice, I recommend let's practice the third one, because we have cotangent as well. Okay. So 1 plus cotangent squared theta equals,
Cosecant.
very good, square theta. And I have cotangent.
Yep.
We determined it because we were given tangent. So we have negative 1 over 4. So then 1 plus very good, equals cosecant square theta, which is 17 over 16. cosecant squared theta. I already established the sign for cosecant. What is the sign for cosecant? So when I take the square root from both sides, I will write cosecant theta equals, very good, the square root of 17 over 4. And since I have cosecant, I have sine.
Yep.
So what is sine?
4 square root of 17.
And I have to rationalize. 4 the square root of 17 over 17.
Wow.
I want to show you an easier method. The reason why I wanted to go through this is because I wanted you to understand how useful those three relationships are. Yes, there is an easier way, and I want to show it to you.
Okay.
Ready? Do we have any questions on this method? Do we understand the method? It's all based on three important identities, and you can't get away from those. Here you can get away from those with a simpler or easier method, but you can never get away from those three. They're so useful and important. Okay, so I am told, we already established that theta is in the second quadrant, we know that, and we are given the tangent theta equals -4. Okay, so there exists an angle that ends somewhere in the second quadrant. It's in the standard position, and this is the angle, right? This is my theta. Of course, this is what we call what? Very good. So for this angle, I am basically told that tangent equals -4/1, meaning this piece is positive because it's above the x-axis, 4, and this piece is negative because it's going the opposite direction of x. How much is this? How much? 1. So now I can easily determine this, which is the hypotenuse in this triangle, which is not the unit circle. Yes, so it's 4 squared plus 1 squared, which is 16 plus 1, which is 17. So this must be the square root of 17. And now I'm going to ask you to give me sine of theta. Opposite over
Oh, that's right. You're using the reference angle.
and can anyone give us cosine theta? Yes, I have to rationalize it, but you got the point. So everything was really out there in front of us in a blink. You can use it, and I recommend it for something like this. But I wanted you to see how we get the same numbers. You can say, but it took you 10 minutes, and this took us 1 minute. True. I just wanted you to see both methods. And then from here, once you have sine and cosine, it will take you another blink to determine tangent, which you already have, cotangent, which you already have, secant and cosecant. Okay? So let's choose another problem from here. And then I would like to show you how to determine the area of a triangle. So from 6.3, 3 through 51, so that's what we're doing, and every other odd. And they also recommended 59. We'll take a look at it in 71. So we want to choose another, and we'll do it with a simple way, or whatever you want. So we choose another, or we are okay. Yes. Do I get to choose, or? I'll choose an easy one. 46. In 46, we are given cosine theta equals -7/12. And we are told theta is in the third. Of course, you will take a blink now. You should take a blink now, right? So we know that theta is in the third quadrant. So this is not the unit circle. So somewhere in the third quadrant, so there is this angle. And cosine theta equals -7/12 means which piece is negative? So one more time, cosine is this over this. This cannot be negative.
Right.
So this must be the 12. And what will this piece be between this point and the origin? That is the -7, indeed. Now I have to determine this one. Will it be positive or negative? This is very important.
Negative. What are we talking about?
This piece.
Oh, yeah. Negative.
Right, it will be negative. So then in order to determine this, I'm going to call it x. I shouldn't call it x. Let me call it y. Doesn't matter. Then I have y squared plus 49 equals 12 squared, 144. The sum of the squares of the legs, y squared plus -7 squared equals 12 squared. From here, I have y squared equals 144 minus 49. When I take the square root, I should get plus or minus, but I already established y must be negative because it's a measure below the x-axis. So 144 minus 49, 95. Okay, so then y will be negative the square root of 95. Negative the square root of 95. They are asking us to determine the rest. So then sine theta will be that's it. And the rest will follow. Tangent will be this over this, which will be the square root of 95 over 7. Cotangent, I will reverse this. So this is 7, the square root of 95 over 95 after I rationalize. Secant will be 1 over this. So this is -12 over 7. And cosecant is 1 over this and rationalized. So -12, the square root of 95 over 95. Yes, this is straightforward. We don't need those three identities, but they are extremely useful and we're going to use them all the time. Yes. Now, I would like to show you how to determine the area of a triangle only when two adjacent sides are given and the angle in between. So if I have a triangle, any type of triangle, and if I'm given the base and the corresponding height, not this height or this height, but the corresponding to the base, then the area of a triangle is base times height divided by 2. Or you can write it as 1/2 times the base times the height. Okay, that's one way, if the base and the height are given, or if I can determine them somehow. Okay? Now, what if I'm given this, so this is, let's say, A and this is B, and I'm given this angle. I'm going to call it alpha. I don't have the height. So this is the height. Okay. The area of this triangle is still base times height divided by 2. But now, since I don't have the height, but I do have this side, I can write it B multiplied by, and in this triangle, you tell me what to write. Now I do have the hypotenuse, and I do have the hypotenuse of this small triangle, and I'm looking for the opposite. Because I have the hypotenuse and I'm looking for the opposite, I can use and I will use which trig function? Exactly. So can anyone give us sine alpha from here? Equals
H,
over,
I'm sorry,
very good, cross multiply, 8 times sine alpha.
A, B.
A, B, sine alpha.
I had B.
Yeah.
I just didn't want to write it A sine alpha. I put A in front. Right? So A times sine alpha is this piece, and B is this piece. I just rearranged it. So it's B times A sine alpha, or AB sine alpha over 2. So I would like to look at a problem like 54 on the same page, 460. Find the area of a triangle with sides of length 7 and 9. 7 and 9. And the included angle 72 degrees. I want to find the area of this triangle. And then for some reason they picked 59, I believe it was. Yeah, 59, and then we'll do 59. Seven times 9 times sine 72 degrees over 2. Whatever you give me, I'll write it. No, I will not. Just somebody will confirm. How much?
29.96.
I trust you. Is anyone else confirming?
Yeah.
Very good.